Let's very quickly look at the electrical stimulation of the heart. Now that we understand the blood flow in the heart, the electrical stimulation is very easy because it lines up perfectly with the blood flow. So we'll take a little box again, and this time we'll put a little bit more detail into it, and then draw the actual hearts. So this is what the heart actually looks like. So if you take someone's heart out of their chest, cut it down the middle, this is what it looks like. At the right atrium, the right ventricle pumps it out to the lungs, goes into the left atrium, down to the left ventricle, pumps out the aorta to every single organ in the body, returns to the right atrium. Now, in order to pump the blood, it's just like a muscle. You have to contract it and it has to pump and squeeze. So it's just like a muscle here. Just think of a bicep muscle. It has to pump and something has to propel that blood throughout the body. Now, unlike every muscle in the body, the heart is autorhythmic, which means it contracts by itself. That's why if you cut someone's heart outside whenever you see like medical shows or whatever, and someone's heart is outside the body, it can still pump by itself. It can still beat because it doesn't respond to neural impulse. Well, it doesn't need neural impulse to contract. Of course, it dies eventually outside the body because it doesn't have a blood flow, but it doesn't need a neural impulse to keep contracting. And now the thing that makes the heart autorhythmic is it's always referred to as autorhythmicity of the heart. And it always starts with the SA node. And the SA node is right here in the right atrium. Now, between SA node pumps, SA node is the most important node to know. I can guarantee that there'll be questions on what starts your electrical stimulation of the heart, what is the main pacemaker of the heart. It's another word. Pacemaker keeps pace of the heart. And the SA node pumps by itself every 60 to 100 beats per minute. This is its age that the SA node pumps. So what this means is every 60 times to 100 times per minute, your heart's going to contract. Is going to contract by itself, 60 to 100 times per minute. SA node, regardless of what the hell you're doing, if you're sleeping, whatever you're doing. Now the signal gets released from this SA node, but remember, the left ventricle is the one that pumps blood throughout the whole body. So the signal has to have a way to get from here to the left ventricle. In order to do that, it goes through different branches and all these little guys, these branches. It travels through these branches in order to get to the left ventricle. So what it does first is the signal starts in the SA node. It spreads to the left atrium. We're not going to talk about that, but that's a different branch. But the main thing is it spreads to another branch another pacemaker called the AV node. Now the AV node is like right here in the middle of the heart, or separates the ventricles. So the signal spreads from here to the AV node, and when it gets to the AV node, it stops for a little bit. And it stops for a little bit in order to allow the rest of the blood, we'll go over to blue now. It stopped because remember the blood goes from the right atrium to the right ventricle. So the signal spreads from here, blood falls down here. And when the signal's spreading, just like a heart with action potentials, that's what this is doing, it's spreading action potential, the heart contracts when the signal spreads. So the heart contracts and it pushes the blood down to the right ventricle. It pumps the blood to the right ventricle. And the reason it stops for a little bit is because the signal moves a little bit faster than the contraction in the flow, moves a little bit faster than the flow of blood. So while the signal is at the AV node, the blood is still falling or being pumped into the right ventricle. So the reason it stops this signal a little bit is to allow the rest of the blood to pump to the ventricle. So once all the blood gets to the ventricle, of course it gets pumped out to the lungs, whatever, we're going to skip that part. But going back to the signal, once the blood gets to the AV node, then it goes down a track in the middle called the bundle of His. So now it's going down the middle of the heart, the action potential. And then when it reaches about right here, it splits into the left bundle branch and the right bundle branch. And just like what its name says, the left bundle branch goes to the left side of the heart, the right bundle branch brings the signal to the right side of the heart. So it spreads between these branches. And when it gets to the right side of the heart, that's when the right side of the heart contracts and pushes this blood to the lungs. So pretty much whenever a signal spreads through something like an action potential, it causes a muscle to contract. So over here, it pumps the blood down to the right ventricle from the right atrium. The right atrium contracts when the signal spreads. And then when it spreads into the right bundle branch, the right ventricle pumps the blood to the lungs. Now, the reason why you have two branches going at the same time is because electrical stimulation and a heartbeat is so fast. So it's very hard to say one is independent of the other. Like the right atrium pumps first, and then the right ventricle. It's very hard to say that. Because in reality, the right atrium pumps maybe at 1/100th of a second before the left atrium. Just it's really fast. So it all goes to the lungs and then enters the right atrium. And of course now it's oxygenated. So the blood enters the atrium. This signal over here that spread, it causes the left atrium to contract and pumps the blood down to the left ventricle. So now the blood gets pumped to the left ventricle. And in the left ventricle, when this signal spreads, once it spreads into the left bundle branches, it spreads into more fibers, little branches called Purkinje fibers. So now that's what these guys in blue are. So it spreads into these Purkinje fibers. And these Purkinje fibers, what they do is they wrap around the back of the heart, because this is just the front of the heart. It has the back of the heart also has to contract. So it spreads to the back of the heart. And at that point, then the signal causes the left ventricle to contract, just like it's a muscle. So now it contracts out the aorta and gets pumped throughout the whole body. And then the signal repeats. And this happens every 60 to 100 beats per minute. Now, going back to now, go to the pacemakers of the heart, because I'm sure this will be a question asked on. Now, the main pacemaker of the heart is the SA node. The SA node beats by itself every 60 to 100 beats per minute. This is autorhythmic by itself with no impulse. Now what happens? Say something in the body causes the make it not red. We'll make it blue. Say something in the body causes the SA node to stop contracting. It kills the SA node. Now, if there wasn't another pacemaker of the heart would, at this point we can deduce that the heart will probably die, because if the SA node is dead and the signal comes from the SA node, then there's no signal to go to the heart. But luckily the body is smart and it has many backup mechanisms. So if this node fails, there's also the AV node. And the AV node can also become a pacemaker. So if the SA node fails, the AV node can become a pacemaker. Now the AV node pumps it's a slower pacemaker than 60 to 100 beats per minute. It's around 60 to 80 beats per minute. So it's a little slower. And now if the AV node also fails, there's another node like right below the AV node called the Junction Node. And that's between 40 and 60 beats per minute. And if that node fails, there's another node down here. And that's between 20 and 40 beats per minute. So as you can see, the closer the node gets to the left ventricle, which pumps blood throughout the whole body, this is the one we care about, the left ventricle. So the closer the node gets to the left ventricle, the slower it pumps. Now, if these nodes die and the ventricular node is the only node that's pumping, that's pretty bad, because again, that's a very slow heartbeat. Now, we'll talk about the reason why athletes have slower heartbeats than 60 beats per minute. Even though they're still using the SA node, it's possible to have a heartbeat of around 35, 40, and you can still be completely healthy. But this is the basic electrical stimulation of the heart, and this follows perfectly with blood flow. Because if you understand blood flow, you understand electrical stimulation. Because the electrical stimulation just essentially mirrors the blood flow. The blood flow happens because the right atrium is pumping to the right ventricle, it's pumping over here, then it's over here, and then it's being pumped over here, then it's being pumped over here. Just like a muscle, something has to be pumping this blood. The blood's not just falling through the heart. Something's pumping it, and whenever a muscle contracts, it has to have an action potential that causes the muscle to contract. So thus there's this action potential going from here, causing that to contract, stopping, going down here, causing this to contract, going here, or wrapping around, causing that to contract. And this electrical stimulation happens every 60 to 100 beats per minute. So now that we got the boring stuff and all the memorization taken care of about understanding blood flow, understanding electrical stimulation, now we can go into the more interesting subjects about cardiac output and pretty much everything that exercise affects and things that we can easily control and make stronger if we want it with exercise.